Okay, so in this video, we're going to talk about volume and how we can find the volume of an object. So let's say we have this fungi looking shape here. Basically, the whole idea behind this is that we're going to take cross sections, and these right here are cross sections. They're perpendicular to the x-axis at a point x, and it gives you like a planar region, a plane. And you can find the area right here, this area here, right? So let's say we were to slice this infinitely many times from beginning to end. So the beginning of the shape all the way to the end of the shape. And you added all of these slices together. So we would sum them up. We call this way method of slicing, and this is a way of computing volumes because you would take these little areas that you would get by slicing and slicing and slicing, and you'd add them all up. Now, it's really hard to specifically do that each time, right? Because that's impossible to do. So instead, we use that idea of Riemann sums. So you want to realize that what you're doing is you're taking the area and you're timesing it by the height of the object. So your volume is equal to the area times the height, which totally makes sense because remember when you do volume, let's say of a cube, it's length times width times height, and isn't that area of the square, one of the sides times the height? So it's the same concept here. So what we're trying to do is we're going to be slicing these lines, and these lines are going to be parallel with each other, right? They're all going to be parallel. And we're going to be using what would be a Riemann sum, but we're not going to use the Riemann sum example here. Instead, I'm just going to give you the formula. So let's say we want the volume of a solid, and it has these cross-sectional areas. So cross-section just means that they're perpendicular to the x-axis. And we want to know from A to B, these x values. Well, the volume will be the integral from A to B of the area dx, where dx represents your height, right? So we're going to go through some steps, and then we're going to answer some questions. So here's your steps. Number 1, do your best to get a sketch of the solid and of the cross section. Number 2, find a formula for the area. And that area, remember, is the typical cross section that you're finding here. Number 3, find the limits of integration. And number 4, integrate to find the volume. So let's do an example. Okay, so now let's apply this volume to an example. A pyramid 3 meters high has a square base that is 3 meters on a side. The cross section of the pyramid is perpendicular to the altitude, x meters down from the vertex, is a square, x meters on a side. Find the volume. So your best bet should always be to draw a picture. Get an idea of what this looks like. Otherwise, we're going to have a hard time figuring out what the volume is, what the radius is, what the disk is, what the shell is, with all of the little components of what a volume could be. So let's get a sketch. We draw on our x and y axis. We draw what looks like a pyramid, and it has a square base. So notice I'm just going to now bring the vertexes, the drops down to the corners, so I can get an idea of what the picture of this pyramid looks like. Okay, so it's 3 meters high, so that's going to be the height of the pyramids, which means that's going to go from the x-axis up until the vertex, and then it's got 3 meters on each side, so that's those 3's, and I just wrote in on the squares. So this point right now is going to be the height, so that's the 3 meters high. Take a minute, make sure you write this all in. If you notice, every little cross section, every slice that I make is also a square. So what we want to do is we want to find the sum of all these squares. Now yes, the square is going to change its width, like the lengths each time. We don't know. It's going to be x. We do know that it ends as a 3 by 3, but throughout it, it could be any number between 0 and 3. So take a look at this cross section, take a look at this slice. And the area of any slice you pick, you let the side be x, would be x squared. So we drew a picture, we wrote the area formula. The next step is to look at what the limits of integration are. And they go from 0 to 3. And that's what that height came in for. So you see where right away it says 3 meters high, that's where that came, that's why you're using that. So it goes from 0 to 3, area dx. So x squared dx. So you get integrate x to the third over 3, and then FTC, sub in the 3, sub in the 0. When you sub in the 3, you're going to get 27 over 3, which is 9, and then 0 to the third over 3 is 0. And I'll write that down. Just keep in mind how we got the volume formula. The volume formula is the limits of integration with the area. There you go. I'm going to put cubic meters because I actually have a unit of measurement here. What you're going to notice is that you want to make sure that you write your formula. And in these type of questions, you don't have a function given. Instead, you have to use your picture and determine the cross section. In the next example, we're going to actually use a formula because we're going to use a different method. But in this example, in this methodology, if there's no function given, see if you can get a picture and see what the cross section is. Also notice that when it comes to an exam, I need to see the integral, and oftentimes I will ask you, if it's like an applied question like this, draw a picture, write the volume formula, and then just give me the answer. However, if it's just an integration question, I usually want to see the integration, which is the x to the third over 3 with the line 3, 0. I want to see the FTC, which is the 3 to the third over 3 minus 0 to the third over 3, and then I need to see the answer. As mentioned in our assignments that I had posted answer keys for, you can use your calculator to get the final answer of 9. You can use function, integrate, and then just put the integral in as you see it. So if you go back and reference the answer key so you can see I give you a detailed way of how to answer those as well. So in this video we're going to talk about volumes of revolution, and we're going to talk specifically about one method called the disk method. Basically, with the disk method, we're going to be taking little disks, the areas of them, and adding them up, finding their sums. So let's take a look at this triangle. And we're going to rotate it around the x-axis. So if we rotate it, it sort of makes this type of shape, which looks like a cone. What we do now is we call this a solid of revolution, because the solid is formed by revolving it around the x-axis. If you think about if you ever had like party decorations, like those centerpieces, and you have to fold it around, that's what you get here. Like if I have to fold it around and clip it, it's like that. Now the area for a circle is pi r squared. But notice that there's like infinitely many circles here that make up that entire picture, that is entire cone. And the radius of this circle is the area of the radius of the circle is going to be that function itself that actually created the side of that shape. So what we're looking to find is the function squared. That's what our radius squared is going to be. So the volume formula is the sum of all these areas, which we use as the integral. So we have a to b of the area of that shape. And the area formula is pi r squared. So you're going to use this formula. So it's the integral from a to b of pi of the function squared. And the function I'm using is r of x. So if you see, no matter what the function is, if it's rotated around the x-axis, you're going to square it, times it by pi, and integrate between those x values. So let's look at an example. Let's say we want to find the volume revolution of y is equal to radical x between 0 and 4. And we're going to revolve it about the x-axis. So it's going to have the same revolution as the sketch I did above. So you should always draw a picture. So you draw your y is equal to radical x from 0 to 4. Now you're going to revolve it. So it's going to be like a round vase, or like the cup of an ice cream sundae without the bottom portion, right? So you revolve it around, and it continues all the way around to the other side. Now the radius of this circle is the function radical x. The limits of integration are 0 to 4. If you notice, right there, that's our radius. The sum of all those radiuses is going to be the integral with that radical x squared. So remember, it's pi r squared. So the integral from 0 to 4 of pi r squared. So it's going to be radical x squared dx. And so remember, you want to see your radical as a fractional exponent. I'm going to put the pi up front. And if you take the square root of radical x, we get just x. So that's why the fractional exponent went away. And then we integrate it, it's x squared over 2. And then we do FTC. So you sub in the 4, and then you sub in the 0. So you get 8 pi, because 16 pi over 2 would be 8, and then 0 squared over 2 is 0. So the answer would just be 8 pi, and that's the volume. You would say cubic units, right? But we don't have to talk about units right now because they didn't give it. So before we continue, remember, this is your formula. Area is equal to pi r squared, and r is the function.